In the previous video, we have seen an overview of climbing stairs problem. In this video, we will solve it using JavaScript. So I'll write a function called climb stairs. This will accept a parameter n, which is nothing but the number of steps in the stairs. So we have seen our base case. If the number of steps in the stairs is 1, then there is only one way to climb that. So I'll return 1. And if there are 2 steps, then we can climb it in 2 different ways. So for the remaining steps, we have a formula: return climb stairs of n minus 1 plus climb stairs of n minus 2. So that's it. That is the program. Let us call it and see if it is working fine. So for 1 it is 1, and for 2 it is 2. For 3 it is 3. So what are all the 3 different ways? We can do 1 comma 1 comma 1, or 1 comma 2, or 2 comma 1. So let us check for 4. For 4 it is 5 different ways. So what are all the ways? That is 1 comma 1 comma 1 comma 1. We can do 1 comma 1 comma 2. We can do 1 comma 2 comma 1, or 2 comma 1 comma 1, or also we can do 2 comma 2. And let's check for 5. So it is 8 different ways. You can take a pen and paper and see if that is correct or not. As you can see, this problem is similar to Fibonacci series. Each time we call the recursion twice. So in every step, the number of calls doubles. So the time complexity of this is big O of 2 raised to n. And we know big O of 2 raised to n is bad. For fairly large numbers, the number of function calls will be huge. So let's see if we can optimize this. So as you can see here, right, if the value of n is 5, then we are calling climb stairs of 4 and climb stairs of 3. Then for this climb stairs of 4, we are again calling climb stairs of 3 and climb stairs of 2. So we are calling the same climb stairs function for the same parameter multiple times. So how can we optimize this is, we can have a map where we store what is the result for climb stairs of whatever is calculated, be it 1, 2, 3, and then reuse it instead of calling this again and again. So I'll create a map called base. So I'll declare two variables, n minus 1 and n minus 2, and I will check if we have already stored the result here. If base of n minus 1 is there, then n minus 1 will be base of n minus 1. Otherwise, I call the function climb stage of n minus 1, and I need to update our memory. So whatever result we have got from climb stage 1, we will store it in the base of n minus 1 so that it can be used in the next recursive call. Similarly, we need to do it for n minus 2 as well. So n minus 2, minus 2 here, and n minus 2 here, and I need to change this variable as well to n minus 2 and replace it with n minus 2. Let us check if it is working fine. For 1 it is 1, for 2 it is 2, for 3 it is 3, for 4 it is 5, for 5 it is 8. So now what is the complexity? So let us just have a variable calls is equal to 0. I'll just increment the calls whenever this climb stage is called, and we will print it and see. So as you can see, the calls is 5. So if I have 50, then again the calls is 50 only. We are not calling the climb stage again and again. So the time complexity has reduced to big O of n. So let us see how many times we call the function if we are not storing. I'll just comment these two lines and run it. As you can see, it is taking long time to run because it needs to calculate for 50, and 2 raised to 50 is, I don't know how huge number it is. So I gave up waiting, and I think it went for out of memory issue. So I changed it to 25. As you can see, the number of calls made for 25 itself is huge. And if I uncomment it, it is just 25 calls. So you can understand now why we need to evaluate complexity and optimize the program. Here we are using recursion to solve this problem. Can we use iterative approach? So let us go ahead and see. So I'll write a iterative function called climb stage of iterative, and will accept the number of steps. So I'll have an array, and I will initialize it with base case. Base of 1 is 1 and base of 2 is equal to 2, and we need to loop from 3 to n. So base of I is equal to ways of I minus 1 plus ways of I minus 2. Finally, I need to return ways of n. Let us go ahead and call this function. Ways of 3, it is printing 3, for 4 it is printing 5, and for 5 it is printing 8. Since we have one loop here, this has a time complexity of big O of n. So that is different ways in which we can implement climbing stairs problem. In the next video we will see Tower of Hanoi problem. Thank you for watching. Hope you liked the video. If you did, please consider subscribing to the channel. See you in the next one.